right, so we are on 6-6 now, and we're going to use our calculator. So if you don't have your calculator, go grab that real quick, pause the video, and then come back. Now, this is the first lesson that we're going to hit here that is not going to be new. This is all going to be review, and so this is right triangle trig. And this is what you are all familiar with when you hear SOHCAHTOA. And so I don't know how your geometry teachers taught you this before, but SOHCAHTOA, I'm going to write this a little bit differently here, and then we're going to talk about what all this means before we identify these terms. So what this stands for is this is sine, and sine is opposite over hypotenuse, and then this is cosine, and this is adjacent over hypotenuse, and then this is tangent, and we say tangent is opposite over adjacent. So that's where SOHCAHTOA comes from. You'll see I tend to write it this way. So this is so, and then ka, and then toa. And then this is just an easy way for me to remember it's opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So what does that mean? So if I have a triangle here, and I'm just going to use this in our trig terms that we've been talking about. So here's our angle theta, and we know that this is our radius, and our radius here is our hypotenuse, and this is my x angle here, and the x angle that is adjacent, so if you think about adjacent, you think next to. So this x angle, if this is my theta, then this is going to be my adjacent, all right? And we know that this is our y value, and if this is opposite of my theta, then this is my opposite angle. Now, be careful, because I could very easily say that this is my theta. Now, this is my reference angle, and everything that we've done so far in trig, we're talking about reference angle, but as we go into all types of triangles, this blue angle right here might be what I'm looking for. If that's the case, then this would be my opposite. And this is my adjacent. Whatever's touching your angle is going to be your adjacent. So if it's the blue, this is my adjacent angle, and this would be my opposite angle. So it's super important that you identify your angles as such. So just kind of our ratios, just so that you've got these here, we know that this is opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. And I know we've talked about this before, but if it's sine, the opposite of sine is cosecant. So remember, S and C, they're opposites. And all we're going to do is flip this ratio. So it's going to be the hypotenuse over the opposite. And then hypotenuse over adjacent, and cotan is adjacent over opposite. So again, here my C value goes with my S value. So super important that you understand what the inverse function is so that you've got your values correct. Okay, so I just said this, but again, it says the opposite and adjacent sides are determined by the reference angle. Now, my reference angle, when we're talking about trig, my reference angle is always this angle that is going to be closest to the x-axis. But as we just look at regular triangles, so if we look at this triangle, we no longer have an xy coordinate plane, right? We just have a triangle. So now we're going to identify our our reference angle as whatever angle is that we want to go across from. So a little bit of geometry gotta knows. So uppercase letters are going to signify angles, and lowercase letters are going to be sides. And then one thing that's important is that A goes with A. So uppercase goes with lowercase, or B goes with B. So uppercase and lowercase are opposites. The opposite side goes with this. So if this is my angle A, so this is my uppercase A, if I go across from this, this is my side. So this is going to be my side little a, okay? And if this is my upper case B, so this is my angle B, which in this case is my right angle, if I go across from this, this is my lowercase b. And then my last one, this is my angle C, and my angle C, as I go across from it, this side over here is going to be my little c, okay? Now, that's really important as we do these, because if you think about, and we're going to get to this in just a second, if we think about the Pythagorean theorem, our Pythagorean theorem says a squared plus b squared equals c squared. So let's talk about this for a minute. What we know is that this value here is always the hypotenuse. And the hypotenuse is across from your 90-degree angle. Now, if I look at this as a squared plus b squared equals c squared, but I go up here and I look at this particular triangle, this side is my a side, this side is my c side. Those are the two legs of my triangle, and b is my hypotenuse. So even though we say a squared plus b squared equals c squared, in this case, my legs are a and c. So for this triangle, it would be a squared plus c squared equals b squared. So don't just look at this formula and say, oh, okay, it's going to be, I'm just going to plug in these values. What's important, if this is the hypotenuse, then these two values right here that we have, these are the legs. And the legs are defined as the two sides that connect at your 90-degree angle. So this is a leg and this is a leg. So don't get hung up on these values. Normally the values really mean something. So if we think about, excuse me, all the other math that we've done this year, the a value is the coefficient on the x squared term, and the b value is the coefficient on the x term. And so these values have meant something. They don't here. It's more important that you understand that it's the leg squared plus the leg squared equals the hypotenuse squared, okay? Now, all this is saying right here is we want to come up with these ratios. So if I'm looking at angle A, that's this first one right here. If I'm looking at angle A, this is angle A. So if I look at sine, I know that sine, and I can come up here and look at this if I want to, is opposite over hypotenuse. So in this case, my opposite side is 14.4, and my hypotenuse is 17. Now, it is not correct math to have a decimal in a fraction, but right now, all we're doing with this exercise is just coming up with our side ratios. And this value right here is a side ratio. This value of A right here is my angle. So it's important that you understand what we're solving for, because pretty soon you're going to have this side of the equation, and this side is going to be our trig ratio, and we're going to work backwards to get the angle, okay? So cosine of A, so same thing. So cosine is adjacent, so the side that's adjacent is 9, and my hypotenuse is 17. And then tangent of A is going to be opposite, so 14.4, over my adjacent, which is 9. Okay, now I'm going to go look. I wish I had another highlighter, but I don't. So I'm going to look at this angle C now, because this is all angle C. So if I look at angle C, my reference angle has changed. So if I look at sine, opposite, so my opposite angle here is 9, over my hypotenuse, which is still 17. And then my next one is cosine, which is adjacent, so 14.4 over 17, and tangent is opposite over adjacent. So what you see is we're dealing with all three of these values, but they're not going to be the same. So sine here is 14.4 over 17, but sine here is 9 over 17. Okay? Now, when we look at this triangle down here, we only have 2 side lengths. So this means we have to find our third side length before we can come in and do our ratios. And so this is a perfect example of one where it's important that we understand where our legs are of our triangle. So if I look at this, this is my right angle, which makes this my hypotenuse. So if that's the case, what I have here, and I'm just going to call this R, because little r, because it's across from my big R. So what I have here is r squared plus 7 squared equals 25 squared. And this is a special right triangle. I don't know how much of this you did in geometry, but if you did this in geometry, you would see that r equals 24 if you had to memorize these triangles. If not, what I have here, if I am going to solve this, is I have 25 squared. Oops. Ooh, that's a bad glare on that. So it's 25 squared minus 7 squared, and it's 576, and then I'm going to take the square root of that value. And when I take the square root of that value, I get 24. Okay, so if you didn't learn these special right triangles, you can still plug it into your calculator. So we know that this value of r is 24. So if I'm looking for sine P, this is my P angle right here. So this is P and this is P. So I can do those two angles right away. So this is opposite, so opposite is 7, over my hypotenuse, and my hypotenuse is 25. And what you'll see is I'll often draw my right triangle and just draw an arrow to my hypotenuse so that it's super easy what value I'm using. All right, so if I do tangent, tangent's opposite over adjacent, so opposite would be 7 over adjacent, which is 24. Okay, now I go to my angle R, that's this guy. So this angle R, if I want cosine, cosine is adjacent over hypotenuse, so 7 over 25. Okay, and then tangent of R is going to be opposite over adjacent. So that value is going to be 24 over 7. Okay, now let's talk about this angle. This is sine of Q. So Q is my right angle. Now, let's think about this for a second. So if I want sine, my sine value is going to be opposite, right? So opposite, which is 25, over my hypotenuse, which is also 25. So this value here is 1. But let's think about what we know right now about our reference angles, 30, 60, 90 reference angles. So what is the sine of 90? Well, the sine of 90 is 1. And so we know this already, and we can always analyze our special right triangle angles. So if this is 90, 30, 60, or 45. Okay, let's flip it over. So this one is asking for everything. This is saying, solve the triangle, find all sides and all angles. So here's what I know. I know that this is 90 degrees, so this is my hypotenuse. I don't know this side length of B. So what I have here is I have 12 squared plus B squared equals 19 squared. And so I can go in here and I can calculate this. And what I have is the square root of 19 squared minus 12 squared. And so this value here of B is going to be 14.73. So I'm just going to use 14.7 as I do these calculations. All right, so first thing I want to do is identify my angle. Well, I know this one because it's given. So A here is going to be 90 degrees. And then I know that the side opposite is the small a, so that's going to be 19. And I know that opposite here, big B and little b, this is going to be 14.7. So this is one that I just calculated. So here's one that I calculated. And then the other thing that I know is this value of C, and small c is 12. Okay, now I can find these other angles. And I can use this a bunch of different ways, but I'm going to say I want to know the angle B. And to find the angle B, I don't know what these are, but I do know that I have a trig ratio here. So I have a ratio. I just picked sine. You could pick cosine. You could pick whatever you want. I picked sine. And so I don't know this angle B, but what I know is that I have 14.7, and this is going to be my opposite over my hypotenuse, which is 19. Now, actually, it would have been smarter for me to do cosine B. And so I'm going to do this here, and then I'm going to show you something. So this cosine B is going to be adjacent over hypotenuse. And here's why it's smarter for me to use cosine. I calculated this angle of B. So if I made a calculation that's wrong, then this is wrong, which is going to make my angle B wrong, right? So it's better to use what was given, which is 12 and 19. But I'm going to do both of these just so you can see that it doesn't really matter. All right, so if I look at my calculator here, and I have this ratio of 12 divided by 19, what I have is 0.63157. That is the value of this. So if I rewrite this, I can case cosine B equals 0.6316. And we learned how to calculate what the angle is when you have the side ratio. So remember, that's inverse cosine. So inverse cosine is going to give me B, and instead of typing it in, I'm just going to go up and capture it. And when I do that, I get an angle of 50.8. I'm going to round that angle, and it's going to be 51 degrees. Now, I'm going to do this one just to show you that it works. So if I take 14.7 and I divide it by 19, this gives me a side ratio of 0.7737. Now, remember, I rounded this number of 14.7. If I go up here in my calculator, it was this number. So I'm actually going to use this number, 14.73, this uncalculated, so that I get the right answer. So if I go down here, I have inverse sine this time because this is what I have. And I'm going to go capture this 14.7 value. What did I do wrong? Oh, I didn't divide it. Sorry. Here's what I have. I'm going to say inverse sine of this number, 14.7, and I have to divide that by my hypotenuse, 19. And what I get is 50.8322. Now, if I look at the one that I did here with this value, 0.7737, I get 50.687. Now, these numbers are just slightly different, and they're slightly different because I rounded this 14.7. So if I use the number that I get when I actually divide this, the non-rounded number, I get 50.83, which is exactly what we had when we did cosine. So this one's just off tiny bit because this 14.7 is rounded, but I still got the number 51. So again, this doesn't matter if you use cosine or sine. Well, then I could do the same thing for angle C, or what's even easier is I know that there's 180 degrees in a triangle, and if I subtract 90 and I subtract 51, then I'm left with 39 degrees. So this is going to be 39 degrees. Now, if I did this, let's just say if I want this angle B, I'm going to do cosine because cosine is my known. So if I do inverse of 12 divided by 19, sorry, I'm looking for angle C. Hello, Shannon. So I'm going to use sine because I want to use opposite. So sine of 12 divided by 19. And this gives me 39.16, which is, remember, we're rounding all of this, but that value would be the same as what I did if I just subtracted. Okay? All right, let's look at one more here where we're given different things. All right, so what I know, I'm going to fill in what I know first. I know angle Q is 57 degrees, and I know angle P is 90 degrees, and I know side P is 19 degrees, or is 19. I don't have a length, it's just 19. So the easiest thing for me to go in and calculate is going to be angle R. So again, I have 180 minus 90 minus 57 tells me that this angle is 33 degrees. And now I can use any of my ratios to find these other two sides. So if I know this, I'm going to calculate little q. So if I have sine of 57 degrees, this is going to be little q over, because this is my opposite, over my hypotenuse, which is 19. Now, if I want to solve this for little q, I'm just going to multiply. So 19 sine 57 degrees equals little q. And when I plug this in my calculator, 19 sine 57, I get 15.934. So 15.9 is the length of this side Q right here. Okay, now I can go in and I can do Pythagorean theorem, and I can say r squared plus q squared equals p squared, or I can just do the same thing that I did but use cosine. So if I say cosine of 57 degrees, This is going to be r over 19. R is my adjacent angle. So if I do the math on this, I would have 19 cosine 57 degrees, and this gives me 10.3. Now, I'm going to check this because I can, and if I have r squared plus q squared, this needs to be p squared. So I can do square root of 10.3 squared plus 15.9 squared, and that gives me 18.94. So it is off just a little bit, but it's off because I've been rounding these values. If I wanted to make it exact, I could take the square root of my 15.9 value squared plus my 10 value and square that, and this gives me 19 exactly. So don't worry if your values are off just a tiny bit because of rounding. That's okay. There's no way we're going to write these great big long numbers in here. So what I would tell you is for degrees, round to the whole degree, and for side lengths, just round to 1 decimal place. In fact, let me write that on here. So we're going to go whole degree and 1 decimal for sides. And just kind of use that as a reference as you do this. All right, let's keep going. So this is easy pre-algebra, but this kind of sets up what we need to do when we've got an x in the denominator. So just to review this, if I'm solving for x, so solving for x means I want x equals. I'm going to multiply both sides of this by 3. So I would have 3 times 10, so x would equal 30. Well, in this case, I don't multiply by 3, or I don't divide by 3 because x is in the denominator. So I have to get x out of the denominator. So if I do that, this switches this up, and what I end up having is x equals 3 over 10. So I multiply both sides by x, and when I do that, I have 10x on this side, so then I have to divide both sides by 10. Now, this is important because this is going to help us as we set up these problems down here. Now, this is only asking us to find the value of x. That's all we need to do. And what you've seen on this is there's more than one way for us to do this sometimes. So if this is my reference angle, this is what I want the angle that's opposite. Well, the only thing that I know is if this is opposite of 23, this is adjacent. Remember, this is my hypotenuse over here. I don't have that value, and I can't calculate that value because I would need the Pythagorean theorem right now. So the only way to solve this would be sine of 23 equals my opposite value. What am I doing? It's not sine, it's tangent. Tangent of 23 equals my opposite value, which is x, over my adjacent angle, and my adjacent angle here is 15. So what I have is opposite over adjacent of this angle 23. Okay, now we just did this and we said 15 times tan 23 is going to give me that value of x. So in this case, my value of x, 15 tangent 23, is going to be 6.37. Or, like we just said a minute ago, 6.4. That's what we're looking for. Okay? Now, I could have used this right angle, and I could have used 90 degrees, but I'm going to use this value that I have here. Okay, so this one, what do I have? I have a side, and I have a side, and I need another side. So if this is my right angle, what's across from my right angle is x. So this just becomes Pythagorean theorem problem. 27 squared plus 34 squared equals x squared. So when I plug this in my calculator, I get the square root of 27 squared plus 34 squared. And so my value of x is going to be 43.4. And again, I don't have units on these yet. As I add units, it'll be something that I'll need to put a unit on here. Okay, last one. So what I have this angle of 39, and this angle is my opposite side here. And what I'm looking for is opposite of my 90-degree angle, I'm looking for the hypotenuse. So if I have opposite and I need hypotenuse, I'm going to have sine of 39 degrees is going to be 15 over x. Now, this is the reason why we did this problem up here, 15. My x value's in the denominator. I've got to get that out. So to get this out, I'm going to move this to this side, multiply both sides by x, and I end up with 15 divided by sine of 39 degrees. So now when we plug this in our calculator, we have 15 divided by sine of 39. So 15 divided by sine of 39. And what we get is that this value of x is going to be 23.8. Because this is an angle, I'm going to say x equals 24 degrees. Okay, that's it.